Today we are going back to our parser for the Redis protocol. We worked on that some time ago, a month almost, and we will go on with more types. We left last time having parsed something, integer strings, simple strings, byte strings, and so on. Now we have to go on with more complicated data types. I think the next one is the array. But before going on with that one, we want just to highlight a couple of stuff that last time were a problem for us. We left a couple of lines commented, specifically the hash map and the set. We found a way to have them in our enum. And the other one is that Luciano created a crate for this small project. So he will show us how to do that.
Sounds good. Thank you for the intro. So shall we get into it?
Yeah, let's go.
Okay, so screen share. You should see my code from last time. Let me know if it's small enough or if it's readable enough, and we'll
Small enough,
adjust.
so if you want it smaller.
Exactly. We can even make it smaller because there is a lot to see. So okay, so let's start with a super quick recap of what we did. So we are trying to parse the Redis protocol, as Roberto said. So the Redis protocol is a human readable protocol. So it looks something like this. You have different data types like strings, numbers, arrays, hash map sets, and so on. And there is the full list here. And then you can receive a string message like this. This is like a simple string. The plus indicates the type, and OK is the content of that value. And then there is always like a closing delimiter like /or/n. And more complex examples, let's see if we can find one. Like, for instance, this one is an hello. Let's see, an array. This one is an array. So it says that it's an array with 3 items. And then we have the first item, which is
Integer, colon
an
is the
integer, another integer, another integer. So this is like a 1, 2, 3. And you get the idea, right? So it might get a little bit more complicated, but the idea is that we want to create in Rust a library that allows us to parse this kind of strings. Ideally, moving forward, we can also parse more structured stuff like specific Redis commands. But before we can do that, we need to be able to parse the specific data types. So that's what we started doing last time. We did a little bit of progress. We created a small project using NULL. And this project exposes a library. And right now, this library only has 2 public things. One is an enum called value, and one is a function called parse value. What value does, it tries to represent all the possible data types, and we'll get onto the commented ones in a second. But here the idea is that a value can either be a simple string, a simple error, an integer, an array, null, boolean, double, and so on. So this value is a little bit like the SERDI JSON value that tries to describe all the possible values that you have in JSON. So same principle, but applied in the context of the Redis protocol. And big caveat here, we are not using SERDI, at least not yet, because we are just doing the parsing and we are using NULL for that. Now, how did we do the parse value? We all implemented the first 4 data types, which is simple string, simple error, integer, and bulk string. We are not super happy with this approach, so we might change it a little bit. But the idea here is that the parse value is kind of the first entry point that can take a string in the Redis protocol, and it tries to figure out what kind of value is this based on the first character. So if it's finding a plus, we know that that's a simple string. If it's finding a minus, we know it's a simple error, and so on. And it's going to call the specific parse function. Now, we believe that there is a slightly better way to do this with NULL, so we'll probably do some refactoring. But for now, this should give you a decent idea of how we structure the code. And then if we're going to look, for instance, parse simple string, it's a NULL parser. We are not going to go too much into the detail of that because we covered it in the previous episode. If you want an introduction on NULL, you can check our recordings. We will have a link in the show notes. But basically, all of these are sub-parsers that are written in NULL and that we can use and combine. And then we also have some... Sorry, Roberto, go ahead.
Just a point. Last time we also asserted that every parser doesn't leave anything unparsed, so doesn't have any rest of the string to parse. I think we have to change that one when we go into arrays.
Exactly. And I think will become apparent why this particular design is not necessarily ideal. We can probably do something a little bit better.
Yeah.
And we also have tests. So the more types we start to support, the more tests we can add to be a little bit more confident that we are doing that correctly.
So my
So,
question is, what was the problem with mash, map, and dash set last time?
okay, if no other questions from the chat, let's cover that first.
I don't see anything in the chat.
But yeah, feel free to drop your questions anyway later, and we can go back if needed. So last time, what we were trying to do, so this is an interesting data structure. It, in a way, is very similar to JSON, meaning that you can have very different data types all combined together in a recursive structure. So one thing that can happen, for instance, is that you can have, for instance, an hash map, which in JSON would be an object, and inside that hash map you have a key, and the value is another hash map. In JSON would be another object, and so on. You can build very nested structures that way. So in the Redis protocol, we need to represent something similar. So we were trying to do this way, which now is commented. So we were basically saying, okay, one of the possible values is going to be a map, and one of the possible values is going to be a set. Now here Rust starts to complain. Sorry, I'm going to stop a second because we have a question in the chat by Jocelyn. Hello, Jocelyn. How are you? Have you heard of Chomsky before? Is that similar to NULL? Oh, I definitely heard Chomsky during university, and it was fun. But this is, I don't think it's similar. Like it's not regular grammar in that sense, right? Would you agree, Roberto? It's probably
I
similar in the problem space, but I think it's a different approach.
It's more a parser, Chams. It's not even untrue that Tom is not a parser. Okay, yeah. It's more a lexer, Chomsky, correct?
What I remember from college, but I hope none of my professors is watching this right now, is that with Chomsky you could define regular grammars, and then you can use that to build parsers and so on. But I'm not really sure it is, I guess, the exact same approach from an academic perspective.
Well, anyway, yes, Nom has his own philosophy.
Oh, there is a crate called Chomsky. Okay. I had no idea about that. So most likely that crate is inspired by the work of
Oh,
Chomsky himself.
probably.
Cool. We'll look out that crate, I guess, later on. But thank you for mentioning that. Okay, so back to the problem here. So the problem
Yeah,
here is that Rust is complaining. Why it is complaining? Last time we didn't really spend too much time trying to figure that out. We just said, let's comment it out and we'll get back to it later. And then we didn't because we didn't have enough time. So now let's try to make sense of it. And spoiler, we did look into it already. So I think we kind of know what's the problem and how to fix it, but let's try to go step by step. So the problem here is that in order to be able to put a value into an hash set, that value needs to be hashable. And this might seem like something we are satisfying because we are saying value, please derive the hash implementation. So in theory, all of that should work. The reason why it's not working, this is a kind of two errors combined together, and that's why it was a little bit tricky last time to figure it out, is that hash map cannot derive hash. So the problem is this hash we are putting here is not working. So this whole data structure is not hashable. Therefore, we
yes,
cannot put it in an hash set.
exactly.
Now, the way we were thinking to fix this, actually in two possible ways. The first one was coming from looking at the SERD JSON type, the JSON value type. And because there they have the same problem. So we were curious, how did they fix this? And the way they fixed it is that they basically use a B3 map here and a B3 set here. So this could be a solution. We tried that and it should work. The other approach that we were thinking, because using a B3 can be slightly less performant, because with an hash map and an hash set, you have pretty much all one access times. So even with very large data sets, generally you can have very good performances. At least the amortized performance is all one. While with a with a B3, you are basically doing traversing a tree, a binary tree. So that is effectively you are comparing items in effectively you have a log n performance. So for small data sets, it's not necessarily a problem. To be honest, with Redis, we don't expect you're going to have massive objects anyway. But to be fair, if we can just get away with an hash map and then only use the B3, use the hash map here and the B3 set here, I think that should work. And we get a slightly better compromise.
And we have to remove the hash in line 19 because we don't need the value itself to be hashable anymore.
Exactly. Meanwhile, we have Christian in the chat. Hello, Christian. And Tommaso saying Rust complaints for different stuff, right? Hash set requires value hashed. Asset requires value hash, yes.
If hash set would require value to be hashable, but we are
but
not
then
using
hash map
set.
doesn't make it hashable because you cannot hash an hash map.
So we remove hash from line 19 and we don't use hash set, but we use the B3 set.
So that should do, and we remove hash from there, and then we need to remove some imports.
In theory, now it should be happy.
At least it's not complaining.
Well, we see when we start to create the arrays and the B3s. When we arrive to implement them, we'll see if it blow up.
Okay, so now should we address the next problem, or do we try to implement array first? What do you think?
What was the next problem? The fact that we need to have a difference between parsing a value that has something left over and having parsing a complete message that will require no leftovers. Is that your next problem?
Yes.
So I think we can do that just before we implement more types. Also because for array, we will already need it. Because when you have array, you say, okay, star 4. Okay, we have 4 values. Then you have to start to parse the first one, and that will fail because it's asserting that there is no leftover, and that is
let's see if we can illustrate that with an example.
I think there are examples for the array.
So if we go in the arrays here, for instance, I think right now we are making an assumption. We are saying if we only have a number, for instance, here, like something like this, we have some tests, I think, for numbers. So let's see our tests. Parse integer, what it is here. So we are saying that if you parse an integer, this one was working, right?
Yeah. This should not be here.
This will fail because it's seeing that there is some leftover.
Yeah, because we have in the parser somewhere asserted that there is an end of file, an EA-off.
Yeah, we say terminated or EA-off. What do we say?
Yeah, I don't remember which one we use of the two.
Terminated.
Okay, yeah. Instead, the value is fine if it's not terminated.
Exactly.
Because it's the message that should be a terminated value.
So I think it's two different things. So this one is probably fine because this is just saying you need to have an I64 and then a CR OLF as a terminator, which I think still stands here, even inside an array, every value is separated by a /or/n, right? While if we go in our parse value, we said that the entire value needs to be terminated by a...
Yeah, the OF is there, okay. Yeah.
The problem
Yes,
is that if we want to parse a single value,
we can keep the parse value, but we can create a parse message or parse whatever, something above the parse value that we left the terminated, but we remove the terminator from the parse value. Parse value is parsing a value and giving me back a rest of the message. Instead, parse message is parsing everything and asserting that there is nothing left to parse when all the parsing is done.
Yes, I think that's a much better approach. But I hope the problem is clear, that basically with the current implementation, we cannot parse a single value and not the entire message. And when we need to parse an array, you will need to parse multiple single values. So you are kind of recursively parsing again for the specific value for every item of the array. So we will be looking for an extra /or/n, which breaks the protocol. So we need to differentiate between parsing an entire message with its own terminator and parsing specific values that might happen inside the message, right?
That could be an idea. Otherwise, Tommaso was asking in chat if NOM has any iterator that can consume stuff. The problem is that also here we are inside a hierarchical structure, like a JSON. So probably it's not just enough to iterate and consume a bit every bit, because we have also to pack them in a tree like a JSON. We can have an array with an array with an array of an hash map, and the value of the hash map can be another array, and we can go on like this forever.
But I think there is a way to make it recursive using NOM, using the combinators. I don't think it requires using an iterator, but I mean, we will need to be able to process an array, and that array will need to call the parse value again, effectively. And when you go into the nested call, it can be another array, right? So you can keep going pretty much indefinitely. I think at some point you might blow up the stack, but it gives you some degree of freedom.
Anyway,
conceptually,
sorry, another comment.
Conceptually, iterator item value is possible. I'm not really sure how easy NOM makes that, if you are basically suggesting that NOM can parse tokens.
Yeah, give me an iterator of values. Yeah, but then how do you detect the level of the value itself? I mean,
unless you want to get an iterator of tokens of some kind, so kind of a lower level.
Yeah, but at that point we are tokenizing, and we are go back in the Chomsky approach, I think.
Okay, there is a suggestion there. Let's open this. Let me open it here. Combinator iterator, what does it do? Creates an iterator from input data and a parser. So what does it do here? Okay, so this is more when you are splitting something, and you basically want NOM to give you an iterator.
But this can be useful for the array, probably, and the array. But the fact is that the array is not delimited. We know exactly how many items we have, and every item we know exactly how long it is, and so on, because the RESP protocol is already smart enough to tell us ahead of time how much space we need for every variable.
Yeah, this could be interesting. I'm not still entirely sure it makes sense for our use case, because our use case can be nested, but let's keep it in mind, because it could be interesting to look at later.
We can look later if we can refactor and make it better.
Meanwhile, there was another question. Is the documentation dark mode? I guess you meant the Redis one. And I'm not really sure, but I think, let's see if I remember this trick that I saw from,
oh my God, what are you doing?
From John Jinxet. So something like background filter
Oh God.
inverse. Oh, I don't remember that.
Luckily, you don't remember that. Yeah.
Was it just filter invert? There you go. Now we have dark mode.
I don't know if I like it, but okay, let's go on.
Is that good enough?
My God, it's terrible.
I cannot claim credit for this one. I saw it somewhere else. Okay, Tommaso likes it. That's good.
Okay, I don't know how can you look at this, but fine. The gustibus.
Okay, let's move on. So we need to refactor this. So we said that we want to do a parse.
Parse mess. I don't know which can be a good.
I suppose we have a parse
Parse everything.
message, which is still gonna be exactly the same.
Mm-hmm. Yeah.
Right.
Yes.
Only needs to call. So
Is parsing
and value.
Is parsing a single value.
Mm-hmm.
Okay. And then it should do the terminated at the end of it.
Exactly. So it needs to do here terminated of parse value, and then here we need to
off
CL or C.
Well, we are not consuming. We are not using the off down in the parse value because we already consumed the CLRRF inside the parser itself.
So here we want to also EOF. But I think we also need to remove that second CL or F. Otherwise, we're doing it twice.
Again. Look at the documentation again of the array. I don't think the array puts an additional carriage return at the end.
Okay, maybe my bad. I thought that was the case.
I don't know. Anyway,
look how beautiful this is.
I trust you.
Okay, so the array doesn't put an extra.
No, that one is the one for word, right?
Interesting. Yeah, this is hello world. Then where did we see an extra one? Was it just in the commands? Like if you receive a Redis command, there will be an extra one, or do I just remember wrong?
I don't remember it, so who knows?
Okay. So does it still make sense to do this change? I think so, right?
Yeah. Because we parse a value. Now that we need array, we parse a value, but we still have all the other values to parse. Mm-hmm. I mean, we got *5. Okay, we have to call parse value 5 times. And we have to keep the input for the next one, otherwise.
Exactly. So this one is basically making sure that at the end we consume the entire string.
In the entire message. If it was an array, it should consume everything. Yes.
Mm-hmm.
And we have to remove the terminated EOF from parse value that is in line 59.
Line 59. We need to remove.
We just have to do parser input as an
exactly.
output.
At this point, we just need to return
parser
input, which we can probably refactor as well. But for now, let's leave it like this. This should work.
What do we want to refactor?
There is another thing we wanted to change, but let's run all the tests first, just to make sure we didn't break anything.
Yeah, to make sure we are still fine. No,
and we did not break. Yes, of course we did break something because we are not using parse.
Yeah, we are not using. Yeah, we have to change it in the tests.
So in the tests,
we have to
either we don't care about this in the tests.
But I think we can use parse message everywhere instead of parse value. Is that working? Can you do multi-cursor magic?
Yeah.
And
I think that should work. And now if we rerun the test, that should be green now. Hopefully, yes. Good.
Okay.
Now the other refactoring I wanted to do is that it's kind of a trade-off between convenience with NULL and maybe a little bit of performance. But basically what I don't like is that here parse value has to see what is the first character, let me call this and that, while NULL can do all of this automatically if you use a different combinator.
You mean with the alt?
Exactly.
The alt piece or machinery, I don't know how to call it, combinator? No, it's
Combinator is probably the right terminology.
Oh, okay, the combinator is the right way of saying. So the alt combinator, you can say parse something. And inside the parser itself, we have the plus, the minus, the colon, the dollar, the star.
Which should make technically our tests a little bit nicer, because then we can also test at this level. Like if we want to test a parse a simple string, you can give it an actual simple string and it should be able to parse it.
Or fail if it's
Or
not
fail
a simple
if it's
string.
not correctly formatted.
If it's not a simple string, it will fail. And alt will take the first one that is not failing at parsing what's next, correct?
Yes.
Yeah, probably is a better implementation, to be honest. Yes, it requires a little bit of refactor. Do you want to do that now, or do you want to do the
Let's
array
do it
first?
now because it was going to be convenient for later when we do the array, I think.
Okay, so let's start.
So U32 or minus, this is just an helper, it's not a type. Then this is another helper.
Is an helper.
This parse symbol string is the first actual one. So here the first thing that we want to do is to get that plus out of the way. So what we want to do is let input underscore equal tag plus. Thank you, Copilot.
He already knows what we want to do.
Was a plus, right? The first one? Yes. Then we have a minus, column, and dollar. Okay. Then the minus is this one. Simple string. Oh, yeah. Why did we do a difference between row and simple string? What was the issue? Yes, because row is also used in the error. So we need to do this one. Sorry.
We do that one.
We need to move it here.
Yeah. There with a plus and in the other one with a minus. Then we use the same function for both of them. Put a minus in that one.
And this one is a minus, yes.
And don't forget, otherwise we are getting mad to find it out.
And then integer was a column, right?
Integer is a column.
So parse integer, we put a column there. And then parse...
and the string, the bulk string is a dollar.
Dollar, perfect. So now, of course, we broke all the tests. To fix the tests, what we need to do is to introduce the alt thing. So basically what we want to do is...
our parser is equal to alt and the list of parsers.
Of list of values. So it needs to be a tuple where I'll look at that. Parse simple string, parse simple error, parse integer, parse bulk string. That should work, minus some parentheses madness.
I think we can remove everything else, correct?
I think we can remove everything else. We will need to take care of all the other types that we're not covering yet. But I think that should do. So I'm going to clean up all of this, and we have an extra parenthesis. And now if we run the tests, hopefully everything is still working. It is. Nice. And we can get rid of this one-off, which we are not using anymore. We were using this
we were using it for?
To make sure that the first character...
to make sure the first character was one of those ones. Okay, right. Yeah.
Cool. So good stuff.
Parse array.
Parse array. So parse array. Now we just need to list them here. And of course, it's going to complain that it doesn't exist. We haven't created it yet.
Let's implement
it. We can do fn parse array. Input string iResult string, and the other one is a value where we expect, and Copilot, calm down. Now, is it an asterisk? Was it an asterisk? Array?
Yes, there is an asterisk.
Okay, so the syntax is number of elements, delimiter, then the first element, then the second delimiter, second element, and so on, right?
I think the delimiter is in the element itself. This the *n is in the element itself.
Yes, correct.
So we have to parse the star, a number, but we already have that everywhere.
So let's parse the star first. So it needs to match the star. So we can just do tag of star, input, blah, blah, blah. Now, here we just need to get, no, this is
A
wrong.
number.
Let input and then length. And this length is gonna be, we have our own helper, right? The -1 thingy. U32 or -1. So
Also, the array can have the -1.
I think so, if I remember correctly. Let's double check that, and we probably need to explain it again. So at this point, we know how many items there are, but let's double check this. What happens if you get a -1?
Null arrays. Probably
Null
is there.
arrays, yes.
What you have to return in case of null arrays? A null
Just
or
null.
an array?
Just null.
Okay, so you
This is what I remember. Let's quickly read it. So it's basically saying there are two versions of the RESP protocol, well, two recent versions, version 3 and version 2.
That RESP has the null while RESP 2 doesn't have the null, and so this is a trick to have a null.
Exactly. And there are a few different ways. For instance, you can even have a string with length -1.
Yeah.
But you can also have an array with length -1, and that should be considered a null. And the thing that here it's saying is that the client should return a null object rather than an empty array. So we are kind of implementing a parser that, if implements this suggestion correctly, is saying, well, if you see -1, you don't have to return an empty array. You have to return a null.
A null.
So basically, what we are saying, and I think we already did this somewhere in the raw string.
For the raw string, I think there was... No, for the bulk string, there was this. Try to look in the bulk string.
There we go. So here what we are saying, if length is -1, so we can literally copy the same thing. I don't know if there is a way to generalize that, but for now it's
probably there is, but let's refactor when it works.
Okay.
And when we have tests.
Now, the next thing that we want to do is, I don't remember exactly what is the combinator, but you can basically, there is a combinator in NULL that allows you to say, repeat a parser n times, and give
we
me
know
an
that
array
times
of
because
values.
it's length. Yeah.
Yes, and the n times is length. Now we'll need to check what is that combinator. So there is a page that is called nom choosing a combinator, which I forgot to open before the stream. But this one is my favorite piece of documentation for nom, because it gives you, I'm going to drop it in the chat as well. It gives you a list of common combinators that you probably can use. So let's see if we can find. So there is a take while, which uses what? A condition. Take till, take until. Sequence combinators. This is probably delimited, preceder, terminator, pair, separated pair, tuple. Okay, applying a parser multiple times. Count. This is probably what we want, right?
Okay, count length time.
2 characters 3 times. So this is reading all these characters. Is reading.
Yeah, so we have to count parse value and times. Length times.
Exactly, yeah, that should do it. So it was easier than I thought. So let's say let values.
We can. This is still... we can return it directly, no? No, we have to return also the leftover input. Yes, you're right.
Which should work. Let's see. This is basically, we need to do count of parse value, and then length as usides, because there we were it wasn't
we have
really a usides.
we have an E32 because it can be -1.
Now count needs to be imported. Okay, at this point we have an array.
So now we return an OK of value.
No way, we need to wrap it because we need to say this is an array. So we need to say now that it's that's it.
Yeah, that, because our definition of array is a vector of values. Yeah, that one. So now we can take from the documentation the examples and try to
write a test. Okay, I was ignoring Tommaso in the chat. Probably you can avoid also to invoke in every function input and just return the function. I'm not really sure. Probably this was way behind. I don't remember. Sorry about that.
Because we call the function where in the alt.
Maybe it was before when we were doing the alt. Yeah.
Yeah, but what?
Okay. FM,
we can refactor always later when everything is green.
Parse array. And let's see what kind of examples do we get from the documentation. Let's go back here. So the first is very simple. It's an empty
array.
So let's start with this one.
Oh, let's see if count is fine with a 0.
So we want to do a parse message of this. And what do we think we are going to get is an empty leftover, then value array of vecnew. That seems sensible, right?
So
we need a semicolon. Now let's run this. And it exploded. Nice. What did we do wrong?
We have a /r/n at the end, because in the array we are not consuming. Oh, why we are not consuming the /r/n after the number in the parse array.
Right.
We have to consume it.
You are correct. It's not just a number, but there is also a CL or F.
/r/n that we forgot. I think we used terminated by CRLF before, correct?
Which should be easy to integrate. So basically,
we do that everywhere. We just forgot to do that.
We forgot to do it in here in the length. So
that is terminated
of C or F of that. That now should work. So this is
because
basically saying
we do the same in line 84. We just forgot to do that.
And this is basically saying it's not just a number, but it's a number terminated or followed by this other parser, which is just checking that is a slash, a CR or a left. And it kind of ignores this result. So it doesn't give you back anything for this. It's just making sure that it matches the structure, and then it gives you this value.
Now, is the test green this time?
Test. Green. Woohoo. Okay, next one. Next one is a little bit more complicated. It's an hello world.
With two elements that are strings.
Parse message. Now we do this. Hello world. And the result should be an OK of Copilot, do the magic. Let's see if that's what we want. So it's a value array of a vec bulk string. Is it a bulk string?
Or is a bulk string. Yeah, but
yes,
string
there is a length. Yes. Hello and value word. So that looks good. Should we try it?
Yeah, let's see. Works.
Nice.
There is also a complicated example of an array with inside an array, but is down below. That is an array of 3 integers.
Okay, let's try this one with 1, 2, 3. Should be relatively easy.
Yeah, but should be more or less the same as one with 2 strings. I mean,
it's just, let's see if Copilot helps us. Look at that. Is it what we want?
seems
Looks close
so.
enough, except that I copy pasted a new line. And okay, value array, value integer 1, value integer 2, value integer 3. Yes, cool. Let's try. Also correct. Then we have mixed data types. This could be
Yes,
interesting.
you have to remove the
New
capture card,
lines, yeah.
because, yeah, the new lines, because they are just for readability. But in the protocol, they are not there.
Okay. I'm gonna autocomplete and then replace and then okay, now it's 1, 2, 3, 4, 5 hello. So there is another one.
The
Which
5 is not a 5. Is the length of hello. Don't get. It's not an integer.
nice, yeah, good
Don't
catch. So
don't
let's
get.
remove this one. Good catch. Yeah.
Yeah,
So it's 5 items. 1, 2,
5
3,
items,
4,
and
5.
the last one is of length 5, and is a hello.
Yeah, very good catch. Thank you. And it works. That's really good. And then there was a nested one, right?
Yeah, I think this one is an array with inside 2 arrays, one of 3 element and the other one of 2. One is a bulk string and the other one is a bulk error.
Okay, let's try to do this as well.
And now let's see if Copilot is so smart to write the assertion equal for us.
So
We already did the null one or not yet?
I
I'm
think
suggesting the null one that we forgot to do, to be honest.
we only did it in the -1, so this might fail.
No, it works. We already implemented it.
Did we implement an explicit null?
Yeah. We didn't copy and paste the if length me, no? Rank.
Okay.
Where are you?
Oh, okay, I see what you mean. Yes. Let
Yeah,
me do the
remove
magic.
the, yeah, do the magic.
Okay,
Okay.
so it's an array of arrays with 3 values. This is 1, 2, and 3. This is the first array, that's correct. The second is another array with 2 values, and it's hello word, but word is an error, right? It's a simple error.
Is a simple error and a simple string.
Yeah, so that
Okay.
seems correct.
So this is a nested structure. Let's see if the nested structure
Copilot is very smart. Probably has seen this example 1 million of times. Yeah,
okay.
seems to work.
Try the -1. We implemented it or not yet?
Oh, you mean as an example? Not yet. Good point. Let's put it at the very top here. Equal, if I can type.
You can copy the line below, but
it's basically
star -1 /.
-1.
Yeah. Instead of a value array, it will
We
be a
want a value
null.
null.
Yes.
And how many parentheses? Do I need an extra parenthesis? Yes.
I got lost with parentheses. We already implemented it.
Perfect. So this was the last
I think
one, right?
this is everything for the array.
Null elements in array.
Oh, well, we
This
implemented
is
that in
not gonna work because we didn't parse the null directly. Well,
yes,
this way,
instead.
yes. This way, yes. So let's
Yeah.
use this one
In
because there
theory,
is also
that one is.
okay. There is also a null itself, a null type in RESP3, which I don't think this example is using.
No, it's not that one. That is using the bulk string version of creating a null.
I have to say that I'm very pleased with the documentation, has lots of good examples.
Yes.
Like it tries to cover all the cases.
Probably as the same that there are in the tests of Redis.
Which is probably a good way of doing, but not obvious. Okay, let's see this. So it's 3 items in an array.
You are missing a semicolon in 216.
Oh yeah, good catch.
And also in 227.
Yes. So, okay, the second value is a null, basically. Right? And then it's hello world as 2 bulk strings. So that should be correct. Run the test. No, this one. All good. So we have a race officially.
Okay, what is the next type?
Thomas say, yeah, we don't pay for parentheses. So you can use
Put another one.
Yeah, if this was AWS, you would probably pay a fee for every 1 million parentheses.
Lisp in AWS make you pay parentheses.
Okay, so the next data structure is null. So now we get into the explicit.
So here we implemented RESP2, I think. RESP2 ends here.
I think so, yes.
Now we are starting with RESP3.
There is a table here somewhere at the top.
At the beginning.
Yes, so from null, everything is only RESP3 and so and on, assuming there will ever be a RESP4. Okay, so let's start with null. So what we need to do is here add a parse null, which of course we don't have yet. So we need to add it somewhere down here.
Probably we can refactor that line 97 and 86 that are replicated. Probably there is a way. Oh, well, we can do that later on.
This 87 and
yeah,
97.
Because they are giving back a null. So if we create a parse null that if it finds a $-1 or a *-1 is matching, and we remove it from the bulk string parser, and then we make length a new size instead of an E32, we can parse the null inside the null parser, but not now. Let's go on like this.
Okay, Tommaso has a good question. We kind of covered this, I think. We haven't benchmarked it basically, but the question is using alt. So this approach here, is there any performance penalty as opposed to just check the first character and then you know with exact precision which one is the right parser?
I think the answer is yes, because I think this one is just testing. If he's not parallelizing, he's testing the first, then the second, then the third, and so on. So he has to fail. It's true that he's failing fast because he's failing on the first character.
Exactly.
He's not parsing 1 megabyte of data and then failing. If it fails at the first byte. So
it should be a reasonable compromise. That's why we're doing it
probably
this way.
as fast as if is a plus, if is a star, if is a minus. And I don't know internally how Rust does the match, probably smarter, but this should not be that super slower.
Yeah, I guess if alt was a macro, and then here you also had some kind of compile time stuff, it could be smart enough to do kind of a prefix tree at compile time. But I don't think that's happening in any way.
No,
it's
I don't think.
just you pay the backtracking, but the backtracking is going to be so small here that it doesn't matter.
Because it fails at the first character of the parsed.
Yeah, and I guess the worst case is going to be in this case null, because it needs to try the first character here, the first character here, the first character here, and then eventually gets to null. But it's still going to be in the order of, 20 data types?
It's checking 5 bytes. It's checking 5 bytes. So
with some function overhead, of course. But
yeah, function calling back and forth for sure. But
so it's definitely a good question, but I think it's negligible. Maybe we'll benchmark it at some point, but we are not looking for extreme performance. Now, parse null Copilot did something. I don't even know if that makes sense. So let's go and read the protocol. And it doesn't make sense. So null is basically an underscore, and that's it. So
Yeah.
super easy. So what
Go
we
on
need to do is
Copilot,
basically
you're drunk.
that, right? Done.
Yeah, done.
Cool. Should we write a quick test?
Yes, but it's very quick.
So test, and we do fn test null, and basically with parentheses maybe.
Nah, let's promote new syntaxes.
And that seems what we want, right?
Mm-hmm.
Cool. Correct. Now the next one is Boolean, probably just as easy to read it now. So Boolean encoded as either a T or an F, and T is true, F is false, and then there is the usual delimiter. So let's do that. Let's do the parse Boolean.
Tommaso was saying in the chat that yes, what we said is true, but if there is a wrong formatted message to parse, the performance issue is that you will find that is wrongly formatted after a while that you are testing all the parsers. Yes, but
That's a good
performance of
point.
performance of bad formatted messages is in the realm of that's an error. I don't care.
But even no, I think it makes sense in general. But I think in the particular case of RESP, the worst that can happen is, let's say, is that it tries to parse, I don't know, an array, and at some point down the line it breaks down. It's gonna revert and gonna look for the next data type.
But there is no data type that matches.
It should fail fairly fast until the end of all the other data types.
Yeah.
So fair point, but I think here is still a reasonable trade-off. We'll need to test it eventually, I guess, to say that with absolute certainty how reasonable it is.
A malicious user tried to take down your server. But well, anyway, if it sends me a payload of 1 gigabyte, I have to parse it. Yes. And if it fails on the last character, it fails.
And the extra cost is just going through 1 byte for every other data type.
Yeah, I don't think there is a way of protecting yourself from somebody intentionally giving you a huge payload and failing the last byte, because you can't know it until you are there.
Yeah, so I think also the protocol has a limit on the sides of
Yeah, we were looking at like the bulk string is 512 megabyte. What was that?
yeah,
What
so
was the limit?
there are also protocol limits that probably help to prevent this kind of
That
stuff.
we are not
but
enforcing, by the way, in
Yeah.
this parser. So we are naive. That's true.
Yeah, definitely very good comments. Keep them coming. But for now, we're going to keep being naive just in the interest of progress. But we should take notes and
Yeah, and
eventually revisit
implement
this stuff.
the real protocol limitations that are written in the protocol. Okay, what is the next
So the
afternoon?
Boolean. So we added parse bool here. We need to create that function. So let's do it here. Fn parse bool input str. If I can type, I result of str and value. Now okay, this is interesting. Here we can reintroduce one-off because we need to check. So it's always an hashtag, that's correct, but then it needs to be either a T or an F.
Okay.
Right? So we can just take the hashtag. I like that it's doing something different here.
Do a terminated, please. Don't do the. Don't.
Here is just saying read while is. No, this is not what we want. Okay,
No,
let's do the first one.
I think he's drunk.
I think it's drunk. Yes, I was a fool. I was trusting it too much. Okay, here let's just do one off. I think it's safer. Char. let's do ch equal one of either t or f.
F. You can do a terminated one off.
Yes.
Terminated
right.
one off t ed f colon
Ooh,
comma.
sorry, messed up.
Where are you? You
I
teleport.
messed up my keyboard. Okay, there. So terminated
outside of one off CRLF. Yeah, exactly there.
And then
Close.
input. And one off needs to be imported.
It was one underline off or one off altogether?
Good point. Import one off from this guy. So better memory, Roberto. Okay, now we need to do a match. That almost right, except we need to wrap the values as in.
But well, the value we can wrap when we return it.
The value, yes, we can return. Okay, there we go.
Input value, boolean of value. Yeah, we can wrap it in last line. So we wrap it only once.
That looks good.
And here we have two tests, one true and one false.
And this one is not possible to reach it because it's not going to pass this one.
Yeah, you can, if you throw in a sharp S, we could assert that is an error, but I think is.
But it will fail before getting here, so we will never panic in the reach.
Oh yeah, we will not even never arrive there. Yes,
assuming that NULL is implemented correctly, of course. Okay, so test fn test bool. Look at that, beautiful.
Add another test asserting sharp S is an error. We asserted errors before, right?
Yes, I'm trying to figure out what did we do wrong here. Do we have an extra parenthesis or a missing one?
No, I don't see that.
Yes, it's missing one here and one here. Okay, and now assert exclamation mark parse message that. It doesn't like an S, it likes an X, but same thing.
I can leave with there.
Correct. So we also have booleans. Let's try the next one. Doubles. Okay, this one might be a bit more interesting.
What is happening here? Save me. A comma. Okay, start with a comma. Optional plus. One or more decimals. Optional dot.
I wonder if NULL has already a parser for this.
Try to look.
So if we look at this guy, is there like
it
a
also is
float?
supporting E and the what's called the exponential form.
Recognizes double floating point number in a byte string and returns an F64. Is that what we want? Let's have a look at that.
What is the RESP2 documentation saying? Is that a float? Because it say the documentation what kind of types you have to return. Sometimes.
Okay, let's keep.
Is a doubles are encoded? Okay, they say doubles up there.
Double precision floating point. So 64 bits. Is that it?
I think it's 64. Yes. Tommaso, if you know that in the chat, please tell me. But I think it's 64.
Okay, so if we get here, what does this look like? Does it look reasonable? Is that what we want?
Yes, it looks reasonable. Yes.
So we can probably use this guy. Num number complete double.
We have just to ingest the comma at the start because that is the protocol part.
So thank you, Num, for saving our life. So what we want to do is parse double. And then we do another function here. We say fn parse double input str I result str value. And now the quote is correct, but again, it's going into that madness of take while.
No. Go.
So I'm gonna take the thingy, but remove the second line, and this is where we need to do the magic. So here we need to say input number, and this is terminated with
double
that guy that was double that we will import CLRF, and now we need to import it. So import double from, yes, this one, and now this is an F64 and we call it num. Let's call it value.
We declared F64 in the enum. Why
Oh
string?
no, we declare a string.
Why?
I guess I don't remember. Maybe we were not sure.
We are not sure, probably. I changed the declaration in the enum to an F64.
It might make sense for a big number to be a string, but not
Big
necessarily.
number, probably yes, because I don't know if Rust has any type. Why doesn't like it?
Ooh, it cannot be equal F64.
Probably for that reason we choose a string. Okay. What do we do now? We keep a string?
We do a string representation of this.
Why not?
Okay, so we keep a string, right? So now here, how do we convert a number to a string?
Or how do we keep the number as it is represented? With a format exclamation mark, you can convert the value to a string, right?
Yes, you can.
I don't know about the lifetime of it.
The problem is that this is going to be an owned string, meaning that it's not going to have the same lifetime. You are creating it. I mean, let's do step by step. So we can do let val as string, and this is going to be that, right? Once we do that, this is a string. Then you can do let val as str, and you do that. At this point, this is a str, and I think it's going to complain about the lifetime. Let's see if that's the case. Yeah, because we are basically returning a reference to a value that is not owned anymore. So I think the only solution there is, rather than using an str, a reference, we can use only a string into the data structure.
If you do in that line at the end, val as str dot to owned is doing something, or no, line below.
This one.
Yeah, to owned.
To owned, I think, creates another string.
Okay.
No. Yeah, creates a string.
Mm.
So the idea is that you can use str only if you're not touching, you're not creating a new string. You are just taking a reference to an existing string or a slice of that existing string. Here we created a new one.
Starting in 30 seconds. If I'm not wrong.
You are correct.
So what if in line 125 we just parse a string and we keep the string from there instead of reconverting it back?
The other approach is that this becomes a string.
Okay.
Right? And then we will need to have a way to convert this into an F64.
But we can implement a parser, right?
Yeah, we can implement convenience methods as double that gives you an F64. So that basically is
the add playing or not?
I'm not sure.
How do we know that? Please in the chat tell us something.
Let's keep going because we have the recording anyway.
Oh, true. Sorry.
So sorry, where were we? Yeah. So here,
let's keep a string. So
now this is working, but of course we can simplify it. We just do val as string and then val as string here. That should be one.
You have an extra closed round bracket? No.
Why not?
No. Sorry. Correct. Sorry.
Too many brackets.
Yeah, I get lost.
Okay.
Test?
Let's write some tests. And then
What are you thinking?
I was thinking a crappier solution, because I guess at some point we will need to implement something like this, like implement that for value a and fn as double, right, of self,
And
that
implement
gives
that
us
only for the
a result of f whatever error or f64. Yeah, for now this is probably good enough. Okay, that might work, I guess.
And if you call as double on top of the enum that is not a double, it's going in line 41, and
Yeah, you always get a result, so you need to make sure did the conversion work.
why is not happy about line 42?
Good point. Is it trying to do a number? What happens here if the parse doesn't work? Yeah, I guess we can probably do our own error type there, but we don't need to get into this now. This was just what I was thinking.
Yeah, I was thinking the same.
Okay, even in JSON you have inserted JSON, you have the same kind of methods if you want to do your own manual, I guess, recursion into the data. Okay, test. I think we can do this other one and we can probably call it a day.
Yeah, okay.
Double. Let's go to the examples. So, are these ones good examples? Probably yes.
There is a comma inf that is interesting.
All right, and we need to see what the string representation generates, right?
We also have to see what the double parser of num parses.
Yeah. Tommaso has another interesting solution, which will be if we create our own F64, like a wrapper, then we could implement our own equality for it, which it will work. I just don't know if it's sensible. I mean, I wonder if you can have weird edge cases where you end up losing items in an hash set or something like that because of your own equality. Like if you have very close by numbers.
Yeah, but I mean, the epsilon should be small.
Yeah, but I guess how small is the question.
For you, in your mind, when are two numbers equal? When the last bit of the mantissa is different? I don't know. Yeah.
Yeah, I guess the degree of precision depends on your problem, and here you will need to provide a generic solution that might not be sensible, right?
I think keeping the string is the most generic solution. I mean, it's a string.
And there is an F64 epsilon, so maybe there is a standard there.
Yeah, but it's a standard based on the machine it's running on, or
yeah,
absolute standard. I mean, if I run in a Raspberry Pico, it's going to have the same epsilon.
Rust doc F64. What does it say? Machine epsilon. Okay, so now I wonder why they didn't implement equal then, if they have this. And it's also deprecated. Replace it by epsilon associated in constant on F64, which is?
It's not the same.
Oh yeah, this one. It's probably just moved somewhere else.
Okay.
This is
That
the difference
depends on
between...
the length of your mantissa, exactly.
Okay, now I just wonder why they didn't implement equal using this. If there is some other subtle thing that you need to keep into account.
Normally in float, I never assert equalities because I don't trust them, but that's just me.
Okay, fair enough. So, okay, we were looking for examples here. So let's start with this one. Let's see what happens. So assert equal of parse as such of this guy. And what we expect is an okay value double of this to string.
Mm-hmm.
Let's see if there is some weird rounding stuff
If there
happening.
is no rounding happening, it could work.
It did work. I am surprised, to be honest, but let's keep going with more examples.
Well, an integer number should not be a problem.
Because the fractional part is optional, the integer's value of 10 can therefore be RESP encoded both as an integer as well as a double. Oh, that's an interesting use case.
Yeah, but we return an integer if it's an integer, we return a double if it's a double. We respect the protocol.
It's not saying that you should convert this to an integer, right?
No, you don't. No, it's not saying that.
Okay, so let's take this and let's have an example for it. Should be relatively easy if I can type today. No, come down. So this without the double thingy,
yeah.
and this is gonna be 10, just as it is. Okay, looks good. Now, infinite, minus infinite, and none. How do we do that?
Try to parse them. Let's see what we have out.
Let's
Depends
start
if
with
NULL
infinite.
supports them, the double from NULL, depends if it supports them.
Otherwise, we'll need to
have
add exceptions.
Yeah. We have to create a none parser, an infinite parser, and a plus infinite parser.
But now also, what is the representation here? Do we just say inf?
Plus capital inf, it could be. Only the I capital in and F. I mean, there is a standard that says that. I don't know if we are using that standard.
We are,
not.
Probably not here. What is the difference? Yeah, it did break even before, I believe.
Yeah, he's not able to parse inf at nom level.
Okay, let's have a quick look at the nom documentation to see if it mentions something like that. Otherwise, we can easily add these 3 exceptions.
Yes.
So if we go to nom and we check
go back to the double,
this one. So recognizes floating point numbers, text format, can parse until the end of the input. Yeah, it doesn't mention anything about
infinite, minus infinite, and okay.
I'm
so
just
we have
curious, if you say that there is a standard, what happens if this was plus inf? I'm just curious if that's supported, even though this is still not what we want.
You have an extra /n, or is just me?
Oh yeah, maybe that was the issue all the time. Let's try again. Was it like this, right? Okay, still doesn't work. But now we have
inf. Okay, so it's not plus inf, it's just inf. So it's supporting it.
Good. So is that a standard?
Seems so, at least for us.
Okay, let's try the other ones. If it supports all of them, that's amazing.
It could be nice if in the non-documentation they could write it.
Yeah, maybe we can do a PR at some point.
Yeah.
So minus inf.
Yeah, I don't know if it's in a generic documentation for all the floating point types.
Okay, that doesn't work. Why?
What is complaining about?
Code float.
You have an.
It's an error. It was not able to parse the float, basically. The minus inf.
Okay. But it's able to parse the inf.
Yeah, so somehow inf works. Minus inf doesn't work. Let me try none. So let me comment this one out. And let's try none. None is just none, right?
No. I'm not sure about this one.
Let's see what happens. This is exploding as well. Oh, it's because it's uppercase.
It's written none, yeah.
Which is
With
not a big
uppercase.
deal. I mean, we just need to change it here. We don't really care too much about the internal representation.
No,
right?
yes. It's the -inf that strikes me why it's not working. We should look at the non-documentation, because inf is working, so why implementing only half of it? There is not something above all these double floating point types, no.
Let's see.
Look in F32 if they say something in the...
Recognizes floating point number in text format. And returns F64. Oh, you mean in the...
in other types, I don't know. Can you look inside the implementation of NUM if you command click on top of...
So here there is a comment which is interesting with sign integer fraction exponent.
Okay, but there should be a next case for inf.
Recognize float or exception. Okay, let's go to this one.
It's taking care of inf somehow.
Recognize float or exception. What does it do? This is again another invocation. This is the function. Wow, lots of big types.
None and inf are there, line 1431, 1435.
Infinity also recognizes.
Okay, infinity, cool. But minus, no, sorry, we don't give you negative infinity.
I wonder if because it's looking at the sign somewhere else.
Cool, but in theory, minus infinity is correct.
No, I'm just saying maybe you can have a plus inf, minus inf.
Yeah, exactly.
But it doesn't make sense to have a plus none and a minus none.
No, so. Plus and minus none. So probably this is something that NOM could improve. I mean, in Python, if you do float plus inf and float minus inf, it works. So
yeah, so makes sense. Let me try quickly to do what is this one? Recognize float. So here is looking
for an optional plus or minus plus or yeah, but where were those inf, none, and so on? They were before this recognized float.
Yes. Yeah, where was this guy used? Recognize float parts. Okay, this was the function, right?
It was double, not float, but I think changed.
It's probably the same, yeah.
Yeah.
So recognize float or exception. Then does it use either recognize float or it's just they are different branches? So
yeah, they are different
it doesn't
branches.
go there. Yeah.
Yeah, there is no minus infinity, so it's not going to work because the sign is in the recognized float. So it's not possible to have a minus infinity with NOM.
So we need to patch it ourselves, right?
Yes. We need to say this could be a double or
I suppose the easiest we can do is just have the four options. Either is an actual float that we can... So that's the last case. The first cases are infinity plus or minus, or nothing, which is assume plus, and then none, and then parse the value as it is.
Yeah.
Okay.
But the double parser already covers none and the inf without a plus in front of it.
Actually, let me try if we put a plus. I think at this point it's just gonna fail, right? If we put
I
a plus
suppose
here.
it's going to fail because we didn't see any of this in the implementation of it. Yeah, it's not recognizing it. Yes.
Yeah, I guess the other thing is if we are gonna encode as a string and then we want to be able to do parse, we have to respect those two sides. Like whichever we parse from the Redis protocol, then what we store needs to be something that we can reconvert into a float, right?
I mean, if you do inf and you try in Rust to parse an F64, is working?
Let's try
I think
that.
so.
Let's go to the Rust playground. And let's say, is there a dark mode before Tommaso
somebody
kills me? There we go. So I have no idea what is this, but let's say, sorry, we need a main, right? Let's keep the main. We say if we do let f64 equal whatever dot parse
inf dot parse, yeah,
dot unwrap. Now let's try the different values. Here we just do inf, right?
no, in the parse, no, not in the parse, in the string,
Sorry, you're right. My brain is already
and a
fried.
semicolon, and then you dbg v.
Yeah, dbg v. So if we do that, what happens? This
V
one
is equal
works.
to inf. Yeah,
This
inf.
one works. Great. Now if we
Yes,
do plus inf, does it work? It does work. And
minus
if we
inf,
do minus, does it work?
minus
It
inf.
does work. And if we do none,
I don't know none, but però do capital N. No,
works as well.
He's doing capital N for you.
Yeah.
No, it's just nom that is not able to parse minus and plus inf. So it's a problem in nom.
Perfect. No, I was just worried that whatever then we store in the string, if we would be able to easily reverse it.
The answer is yes.
But yes, cool. So we only need to patch nom and it should be relatively easy at this point.
Nom.
So I guess here what we need to do is we have two options. It's always a comma there.
It's always a comma.
Then we have
then we have an OPT.
an OPT.
An OPT, and one of the options is terminated CRLF. Is one option.
So we have OPT of. Sorry, OPT is optional. We need an alt.
Oh, sorry, alt. You're right. Fuck.
And
terminated double CRLF, or we do the terminated around.
We can do the terminated outside.
Okay, so this is an alt double comma.
Yes, so it's either
a double or a
let's do first the
minus.
tag plus inf, right? Tag minus inf, tag none. Yes.
But none is already done by double. Minus none doesn't make sense.
No, it doesn't make sense. And then double. Now the problem is that they return different types. So I guess we need to do a map. I think there is a map where we can say something like, how do you do none f64 infinity? Yeah, is that gonna work?
Negative infinity. Infinity, yeah.
Perfect. And now here we want to do
I mean, the 128, the none double implements the none correctly. So line 128 is probably not needed. The non-parser double is
yes, that's true.
done correctly. No, it was working.
That's true. I guess it was more for my mind to be explicit, but you're right.
Okay, leave it there then.
Let's
Fine.
put a comment and let's say
This is already handled by double.
yeah, note this is already supported by NULL. And also inf as well. Inf without the sign.
Inf
right?
without the plus, yes, that is already supported.
So we can probably do the same and do this just for consistency. And this would have been infinity. Okay, now at this point we can say input question mark.
You put the terminated around it.
Or we could put the terminated around it. Yes.
Yeah, terminated
of all of that.
Comma,
And the
CRLF. And then we hope to have all the parentheses in the right place.
And then this is let input
comma value.
And now it should be a float map needs to be imported, non-combinator map. And the issues that here there is a tag that we don't care about. Now the value is not this one anymore.
No.
Value as a string.
Okay.
That should be it, right?
Mm-hmm.
And if
do you want to open a pull request against NULL?
Ooh, this already exploded. Why did it explode?
Because you have plus inf.
Plus inf. Test. Which is not supported.
Capital I is a problem.
Wait, but what we need to accept here is either inf, minus inf, or none.
Yeah, but go back in our implementation that we just wrote.
So this one shouldn't be there. Sorry, this one here. And
the
then it can be like this, right?
Mm-hmm. Okay.
Let's try again. Okay, that works. Then the other one is minus inf. That now is going to be stored, I hope, as minus inf. Let's see. No, it's going to be stored as
an error.
Okay. Tag.
Hey, but I was saying the I of inf in the tag is capital or lowercase? Uppercase or lowercase?
Let's check. I think it was lowercase, but maybe I'm wrong.
Where is the parse float?
Lowercase.
So why is not matching? You have to remove the /r/n because we
parsed yeah.
133.
Good point.
It. So also plus inf is going to work now.
Which I don't know if we even want to support.
But leave it there.
It's kind of a weird edge case that maybe our client supports, but others don't. But whatever. Okay, now it's working.
Uncommented.
So should we add the plus inf again?
Try. I don't know if it's plus inf or just inf when you compare it.
Let's see. Just inf.
It's just inf because obviously the plus is.
And now the none. And this thing should be uppercase. Let's see if that's
because it's Rust that is uppercasing it, not us.
That should
cool. I think we can call it a day. What do you think?
Yes, and just very quickly, I'm gonna mention that what we did is, if you're curious, in the repository.
We forgot about it.
That I have gh repo view. Come on. It doesn't show me the URL. Yeah, no, there it is, the URL. So I can copy paste this in the chat. If you want to check it out, I'm gonna do a quick commit. Fit or this realization.
array null and flow and double.
Plus refactoring. Okay, so you can find all of that. And then one thing we did last time, if you're curious, there are some GitHub actions to do testing when you push or do a PR and then release. If you create a release on GitHub, it will publish it on the registry. There is a version published now, which was our previous version from the last stream. I don't know if it makes sense to even publish a new version because this is not complete, but basically we put in place the structure to make this a more realistic library.
We will publish at the end of all the
Probably makes
streaming.
sense.
Yeah. So let's wrap it up. You can find the recording on YouTube. The link is on Twitch in the About section. If you're watching this on YouTube, we do live streaming on Twitch every Monday, 6 p.m. Dublin time. Make sure to check the Twitch link in the YouTube description. Give us a follow so that you can be notified. Feel free to leave us comments and open pull requests. Everything is accepted. We are trying to learn Rust, so don't expect our solution to be the best ones. Thank you for all the collaboration in the chat. Okay, and looking there because
everyone.
we have Twitch. Bye.